I developed a project. It's called Plasticula, and the name comes from plastic and cuticula, and cuticula is like the outer shell of an insect. I was looking at insects and at the chances that they offer for us to develop new materials in the future. And basically my main goal of the project was to develop a bioplastic or a biodegradable material from chitin. And why bioplastic and why chitin? Bioplastic, because I was very fascinated, and I still am, by the whole plastic mess that we have. And also in textiles, it's a big issue, and I'm sure most of you are very aware of this. And then you have images like this, and you have people that say this is the plastic age now, like after the Iron Age and the Stone Age. Now we're in the plastic age. And yeah, this is what landfills look like these days. And this is what animals look like these days. So I was very driven by, hey, I want to do something with that material. And I figured out that there are a lot of problems with plastic, but you can sum it up to a few. And one is that plastic lasts so much longer than it's used for. In a lot of cases, it's used for just a short amount of time. It's used for much longer than, for much shorter than it lasts. Recycling never really worked. So in the world, we recycle 9% of all the plastics that we have. And you can see that then 80% of all of the plastics that we create end up in landfills or environments, and the rest gets burned. So that leaves us with a lot of trash in the world and a lot of stuff that literally clogs up systems. And I thought it's time to draw a line, so I'll use the line, and to start to transform this material, because I feel like there's so much plastic in the world already now. It doesn't help to just make a material. It's time we have to actually take the material that we already have and transform it into something else. And then I stumbled across these little guys, and they are mealworms, very common insects, that actually have a funny property, and that is that they can eat plastic, in that case styrofoam, and digest it and break it apart. Their gut has a bacteria that just can dissolve it and turn it into something that then plants can use again. So it breaks it up for plants. And everything that comes out of it is compostable. So it's really interesting. At the same time, the same insect gets farmed a lot for protein. So it's seen as the protein source of the future, and insects are like the food of the future. And actually at the time, that was 2018, the EU had just released a new act and a new policy, and it was the Novel Food Act, that actually also allows European countries to now sell insects as normal food for human beings, which in other parts of the world were already pretty common, but in Europe it was still a weird thing to do. But now it was allowed. So there were a lot of companies starting to farm insects, and especially these worms. And it's really interesting because these worms actually really just eat the styrofoam. So I bought a bunch of these worms and just moved them in with me into my student flat. And I built a little farm for them so I can have an overview of them. Also because they develop in different stages. So at the beginning, it's actually not a worm, it's a beetle. That's like the adult of that insect. And then the beetle lays some eggs, and the small, tiny, tiny worm hatches. Then if you feed it, it grows. And then they actually take the worm usually to make protein out of it when it's a certain size. And then the worm pupates, so like a butterfly, it goes into sleep for a week, and then it turns into a beetle again. And that whole life cycle takes half a year. And eventually, after 2 or 3 months, the beetle just dies. They lay a lot of eggs and then they die. So I thought that's really interesting because then I only have, after this life, I only have the warm skin because they shed their skin when they grow like a snake. And I do have the dead beetles, which I found also really like interesting as a source. And both of them are made out of this one protein, polymer, and it's called chitin. And chitin is actually, when you look at it, then it's everywhere in nature. It's in crustaceans, it's in insects, but it's also in mushrooms. It's the second or third most abundant polymer in the world. And it's really fascinating because it comes in nature in so many different ways. So it's like, can be super shiny and like colorful, like on this beetle, but it can also be see-through, like in this shrimp. It can be very lightweight, like in the wing, but also strong, like in the small structures in the wing. And it's actually the most elastic material as well that we know in the world, because in a grasshopper's joints, that's the also chitin that is in there, and it's like super elastic. So I basically teamed up with a company in close to Berlin that makes dog food out of mealworms, and I got some beetles from them. And then I extracted the chitin out of the dead beetles. It's a pretty like easy chemical process to get it out of it because it's only base and acid that you use. And in the end, you can make a derivative out of it, which is called chitosan, which then you can use with a light acid, like a lemon juice, for example, to make anything like see-through foils and stuff. So I started experimenting a lot with that. And I started experimenting with colors and shapes. And like also I looked into, can I recycle that material again? And in the end, I made some foils and some bags out of it. And in that case, I pack the worms themselves, like they are freeze-dried, so you can eat them. I pack them in their own shell. And also the inner little pot that you see, that's also made out of old tea leaves and chitin. Yeah, so this was the first generation. This was what I did in the Green Lab. And then at the end of last year, I did another version of it because I found some new papers, and now developed like even more see-through material from it that is like pretty crisp and clean, and really just works like a plastic foil, with the one difference that it actually degrades pretty quickly. It's actually really good for plants when you throw it onto your compost. And also you can basically like wash it down in really warm water. So that's like the material cycles that I tried to link in this project, was to link the styrofoam process with the mealworms and the food protein process, and then take the leftovers from that whole process to make a packaging for them, for this new industry, but also for anything else, basically. Yeah, so, and then because I feel like I always felt like I want this to develop further, but at the same time, I won't be the one to bring it into the market probably. So I set up a website, and I tried to share as much as I can about what I know. And I shared like samples. I also share the steps of how to make it. And I had already a lot of people to reach out to me that they want to do that themselves. So I'm trying to share as much of my knowledge as I can. I feel like the plastic problem is so hard to tackle and so like wicked. It has so many faceted sides that this was like another approach for me to tackle it. And with them, we like build them. I developed a machine over 1 year to actually make alternatives to plastic from food waste. And I'll just hop through it really quickly. Basically, the machine is now, you can make like plates and cups and stuff from it, coffee cups. And basically there it's the same principle. We made material books, and I made like a lot of plans on how to build these machines, and we made videos about it. And now the whole idea of the project is that everywhere in the world people can start building these machines themselves and start to work locally. So all of the materials in the material book, for example, are made for all of the different places, because I think this idea of like localization is really important to push us forward. So this was the approach, to actually get to a place where, yeah, everyone in their local place can start to make something from waste to replace plastic. And if you want to learn more about that, it's on beyondplastic.world. And it's all open source, of course. And I'm really happy if you have some feedback from your local places, especially in places like Bangladesh, where the plastic waste problem is so different than here.